Oops, I was muted. This will be how to find the surface tension of a droplet using the optical pendant droplet method. Assuming you've already got your photo of your droplet, it's pretty easy to use ImageJ. There's a plugin called Pendent Drop. It's a great plugin. And so I thought I would just put this out there. So it's a pretty useful resource. And, you know, everybody should be getting surface tension analyses of their samples. It's just good data to have. Okay, so I've opened already ImageJ. I have the Fiji version. I just drag and dropped my pendant droplet photo. First up, let's just get it the right way so it looks better. Now I'm going to crop this in just so we can see it better. Next, what you want to do is draw a line and set the scale. This will calibrate your, I just saw, it looks a little, definitely spend a lot more time. Don't do this as quickly as I am here. So the needle we're using here is a blunt tip needle with a diameter of 1.27 millimeters. You should be able to find out your needle tip's diameter from the manufacturer or just by measuring it yourself. Okay, great. Then you need to have a monochromatic image. Next, we are going to draw a rectangle around our droplet. Now it's ready to run the plugin, which is pretty good at automatic. Yeah, look at that. So if you can see here, we are getting our data based off of this red outline. And so it's a fantastic plugin at just quickly finding and getting you started, but you definitely want to make sure the fit is better. As you can see here, we've got some empty space and here it cuts in too wide. So typically the first thing that you can do is get your X and Y coordinates correct. This corresponds to the tip point down here. This looks pretty good, but it's too far to the left. So I'm just going to shift it over. That looks good. You can get pretty pedantic, but you should try not to. Now at any point here, you can click the button Fit Parameters checked below, and it'll run through an automatic fitting process for all of these. If I have all of these ticked on my computer, then it is going to crash. So that's why I manually find X and Y. You know, I'm looking at Y. Okay, I said I wouldn't get pedantic here, but that's better. And so it's the easiest thing. You're gonna have a good judge of that. So that will get rid of one parameter. Now, tip radius and capillary length are the ones that control the shape. The first thing you're gonna look at is how good does it fit down here. As you can see, it's a little too thin. So let's increase our capillary length a little. Oh, did that change the? Oh, sorry. Capillary length changes. So let's change tip radius. I don't know why it has so many. We're gonna have to guess what the tip radius is. Okay, that's too big. That's way too small. As you can see, it's just a little bit of trial and error. I'm a little annoyed that I don't know why it's suddenly having, like, I can't see the numbers. I'm sure it's fine though. Let's try an automatic fit. Let's see what it gives us. Oh, that's really good. That's really good. Okay, I should have just let it do its thing. Yeah, this looks great. So as you can see, it fits really nicely down here. I would say it's a little cutting in up here. You can see that white spot there. Now that's maybe, looking at this closer now, that's maybe because this yellow box, I actually put it too high up on the needle. So I should do this again with the box a little further down the needle. Let me start that. Okay, I was messing with it for a minute, and I think that this is good enough for this example. However, definitely if this was an actual data set, I think that the issue we've run into here is that the droplet was, sometimes we can get is a little bit of creeping up on the size of the needle, and that does mess up, you know, it's not a perfect droplet then. And so I would not be happy with this because it's just not, it's not, you really want it to be a perfect fit. I don't like it. But you get the point. It's a great resource. And once you're finished getting the red line, we're just gonna go ahead and hit OK. And it will give us our results. So you want to record all of the parameters just so you can keep track of that. But then the actual value you're looking for here is the surface tension. So bingo. So that's what you would write down. And in general, you should be taking at least 3 photos per droplet and getting an average there and making sure that they're showing consistent results. And then you should also be doing multiple droplets of every sample. So just in case the way that you're creating that droplet changes slightly, you should be able to still see a strong similarity, a statistically significant similarity in the surface tension value that you're getting at the end. But it takes a little bit of work, but you get really good data and it's fascinating. So yeah, I hope that was helpful, and have fun finding the surface tension of your samples.